Good morning to all of you there. Once again, we are meeting here, and then today, for a change, from algebra I want to change to vector. Yeah, we'll come back to algebra also, because I have done few problems from permutation and then a couple of them from combination. So we shall be dwelling on that. But for today, we will do the vectors. I hope all of you know that I have given all the notes, available notes on vector, but still I wanted to be sure, and probably today's lecture you will understand something more about vector. Okay, right. For example, suppose I have written a problem here, but I am not coming to the problem right away. So before doing the problem, you can copy down, of course. I shall be discussing something. Suppose A is given by, say, 2I minus 3j plus k. This is obviously a vector, and I cap, j cap, k cap, these are the unit vectors. All right, unit vectors, they call it unit vectors because their directions are different. I is along the x-axis, j cap is along y-axis, and k cap is along z-axis. It is in the three-dimensional space. Well, their directions are different. That means their direction, to be precise, they are orthogonal, because x-axis is perpendicular to y-axis, y-axis is perpendicular to z-axis, z-axis is perpendicular to x-axis again, right? Okay. Now, suppose we call this one I. When I write this, what do you understand by that? Because I cap has been surrounded by two vertical lines. So that gives you the magnitude of I, which is equal to 1. Because all of us, we know that a vector is a quantity which has got magnitude and direction. Well, the direction, about the direction I told you, I cap has got the direction along x-axis, but the magnitude of I cap is equal to 1, so is the magnitude of j cap, it is also 1. And also the magnitude of k cap, right? Okay. Now that is all about the unit vectors. Suppose A has been expressed as 2I minus 3j plus k, right? So how to find out the magnitude of this? Magnitude of A will be equal to what? It will be equal to the square root of, see, the magnitude is equal to the square root of the sum of the squares of the coefficients of I, j, and k. So sum of the squares. So coefficient of I is 2, square root of, and coefficient of j cap is minus 3. So we'll write minus 3 square. Plus, what is the coefficient of k cap? You see nothing, but there is 1, yeah. So 1 square. So that is how we define the magnitude of a vector. That is sum of the squares of the coefficient of I, j, and k. So 2 square minus 3 square plus 1 square. So accordingly, you will see that this is 4, 9, 13, and 1, 14. So this will be equal to 14, right? Okay. Now, what about the unit vector? This is a vector, all right? Suppose A is a vector like this. Then what could be the unit vector here? Say it has been divided into several parts. So one part will be the unit vector. So how do we do it? The unit vector along A unit vector, this is a good concept, along A, vector A is given by vector A divided by the magnitude of A, right? Okay, I think you also know that the magnitudes are denoted by the vertical lines on the sides, right? Like this one. But if you write A without the bar, that also denotes the magnitude. That means this is equivalent to this one, right? So in case you are running short of time, so you could write A like this also. That will be scalar A, that is the magnitude only. So here, unit vector along A will be this. So unit vector of this A will be what? It will be unit vector along A. I'm continuing from there, okay? Here, right? This will be equal to what? It will be equal to A. A is 2I minus 3j plus k cap divided by, that A is root 14. So it could also be written conveniently as 1 upon root 14. Is that right? We can just take it out. And within bracket we can write 2I minus 3j plus k cap. Alright. So for practice, I'm going to write a few vectors here. You please try to find out the unit vector along those vectors, okay? Okay. Please take down exercise. Find the unit vector along the following vectors. It's shaking. Okay. Number 1, I minus j, right? I'm not writing k. So obviously the coefficient of I is 1, coefficient of j is minus 1. So you are going to find out the square root of 1 square and plus minus 1 square. Answer can be given mentally also, that is what? That is square root of 2. Okay. Similarly, this one, 7I minus 4j plus 5k. Number 3, minus 4j plus 7k. All right. Number 4, more you do, more you make yourself perfect. So I'm giving you a lot more. Say minus 3j plus 4k, all right, plus 5i. I'm writing I at the bottom, that means behind. Okay, 5 minus 7i plus j plus k. Okay, that much will give you enough of practice to find out the unit vector. All right, unit vector. Now next I'm going to discuss about the dot and cross product. Okay, we'll now try to recall about the dot product. Okay, dot product. Now another popular name for the dot product is also scalar product. Scalar product. Because though we have the product of vector, in dot product it boils down to a scalar quantity. That's the reason it is known as scalar product. How? The dot product let us write it down. The dot product of two vectors, okay, vectors A and B, of course, all right, A bar and B bar is denoted by A dot B, that dot has to be distinct, okay, A dot B, and is defined as, what? Defined as A dot B is equal to A, that is magnitude of A, right, multiplied to magnitude of B and cosine of theta. Now what is theta? Theta is the angle between the two vectors, where theta is the angle between the two vectors. Okay, suppose this is your vector B and that's your vector A, and there is an angle between A and B, right? Since this is B and that's your A dot B, and this is your angle theta. Is that right? Okay. Now, why it is called a scalar product? Because this is scalar as you know it, and this is also a scalar, and theta is an angle, it is just a number. So cosine of that number is again a scalar. That's the reason it is also known as a scalar product. Is that right? Okay. So suppose, find the dot product of, a simple example for you, find the dot product of, say, x equal to I minus j plus 3k and y is equal to 2i minus j plus 3k. Obviously, x and y are two different vectors, so its magnitude and direction are different. And the angle, there will be some angle in between them, right? Okay. So what happens? We try to find out the dot product. So A dot B, mind you, one thing I must tell you, what will be the dot product of I dot I? Tell me. Because I is a unit vector, right, along x-axis. So I dot I, what is the angle between them? Between them, the angle is 0 because they are in the same direction, right? So this will be what? I and cosine of 0 degrees. But cosine of 0, as you all know, that it is 1. And this is also 1, we have seen it. And this is also 1 because this is a unit vector. So this turns out to be 1, unity. So also j dot j will be 1, and k dot k also is going to be 1, right? So these are the things. Now we want to find out the product of x and y, dot product. So instead of writing this, I have to write x dot y therefore will be what? This x is what? I minus j plus 3k, okay, dot 2I minus j plus 3k. In the meantime, you try to tell me what will be I dot j. I dot j. Suppose if it is I dot j, how are you going to define it? I, magnitude of I, magnitude of j, and cosine of the angle between I and j. But I is along x-axis and j is along y-axis. The angle between x and y axis are 90 degrees. Is that right? And we know that cosine of 90 is 0. So I dot j will be equal to 0, so that j dot k also will be 0 and k dot I also will be 0, right? So that means in nutshell, what can we remember? The dot product of two different unit vectors are 0, but dot product of the identical unit vectors are unity. Is that okay? So what do we do? Suppose I dot I will be 1, I dot j, because dot is there, I dot j will be 0, I dot k also will be 0. So in short, what are you going to do? You just try to find out the dot product between I and I, j and j, and k and k. Reason is why? Because I dot I is 1 and j dot j is 1, k dot k is 1, and the dissimilar vectors, unit vectors, they will have the product to be 0, right? So that will be equal to 0 here, right? Okay. So I dot I will give you what? I dot 2I. Then minus 1j, that will give us what? That will simply give us minus into minus is plus j dot j, right? And plus into plus is going to be what? Right? Plus into plus, that is going to be plus 3k dot 3k, 3k dot 3k. So what are you going to get? I dot I is 1, so this will be simply 2, and this is 1. What about that? That is 9. So it turns out to be a scalar quantity 12. That's the whole reason why we call it a scalar product also, because two vectors, when they're having the dot product, it is also denoted as scalar product, owing to the reason it boils down to a scalar quantity. Okay, right. Oh, before I forget to tell you, A dot B, right? We have defined as A and B and the cosine of theta. Is that right? So this could also be written as what? B, A and cosine of theta. That turns out to be B dot A. So A dot B and B dot A, they are what? They are commutative. That means it will denote that dot product is commutative, right? Okay. Yeah. Now we shall discuss a little more about dot product before I switch over to scalar product. Okay, right. Okay, I wanted to discuss a little more about the dot product. Okay, say A and B are two vectors. Okay, or shall we say let okay, well, we assume that A and B are two vectors, then as we know, A dot B is given by what? A B, you could write like that also, A B cosine of theta. Now what is theta? Theta is the angle between the vectors A and B. Okay. Now case 1, when A is parallel to B, what will happen? When A is parallel to B, this will indicate that theta will be equal to 0, right? Theta will be equal to 0. Therefore, A dot B will be equal to simply A and B. That's the beauty about it. When they are parallel or when they are collinear, right? In that case, it will be this result, since y cosine of 0 is equal to 1, right? So number 2, these are the special cases when A is perpendicular to B. Now it is perpendicular to D, that means theta will be equal to 90 degrees, or more specifically it can be also be written as pi by 2, right? Because pi is 180 degrees, that you know, pi radian is equal to 180 degrees, so pi by 2 gives you 90 degrees. So therefore, this will indicate what? Therefore, A dot B in that case will be what? It will be equal to simply 0. This is a very important result. If two vectors are perpendicular to each other, the dot product of the two vectors turns out to be a naught. It's 0. Since, you could say, since cosine of 90 degrees or cosine of pi by 2 turns out to be 0. That's the reason. Okay? Right. Okay. In this respect, we can cook up a certain example. Say, so we have taken one example here. Find the value of lambda when A is I plus j plus k is perpendicular to B, lambda I minus j plus 3k, right? So here we are going to utilize which property? Because these two, A and B, are perpendicular to each other, so A dot B must be equal to 0. So this property will help us to find out the what? The value of lambda. Since, you just make it short, since A is perpendicular to B, right? So this will imply that A dot B will be equal to 0. Let's find that out. Okay. Now A dot B, so A has been expressed like that, B has been expressed like that. So you put down the value of A and B, I plus j plus k, right? Dot lambda I minus j plus 3k. That must be equal to 0. A dot B must be equal to 0. So this dot, that dot must be distinct here, will be equal to 0. So now you try to find out I dot lambda I will be lambda into 1, that is lambda. J minus j will be minus 1, and that will be plus 3. Is it okay? Must be equal to 0. So you can say lambda must be equal to 3 minus 1 is 2, so it will be equal to minus 2. That's the answer, right? That's the way sometimes they set some short question so you could solve it like that. All right? Okay. That is that. When it is parallel, you can just do it accordingly. You'll put down the first condition. Okay? This is the condition for parallelism. This is the condition for perpendicularity. Okay?